In science, we use significant digits or figures to be more precise. Measuring instruments have some degree of uncertainty. For example, if I have a graduated cylinder that measures every 1 milliliter versus a graduated cylinder that measures every 10 milliliters, the 1 milliliter will be more accurate. Second, there's an uncertainty in measuring. Using the example above, if the red line represents the liquid level, one person might read the measurement as 15 mLs, another person might read it as 14 mLs, another person might read it as 16 ml. So there's an uncertainty when we are measuring. And the last reason we use significant digit is to minimize errors. We can't estimate values that are not present. There are 5 rules for a significant digit. The first rule states, all non-zero digits are significant. A non-zero digit is 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I look at the first example, there is no zero present. Therefore, there are 5 significant digits. Every single digit here is significant. For number 2, there are 3. 6, 9, 7 are non-zero digit, but this one right here is a 0. So 6, 9, 7 are the only significant digit, so there are 3. Pause the video and try 3 and 4 on your own and check your answer. Number 3 should have 2 significant digits. 4 and 6 are both non-zero digits. For number 4, there should only be 1 significant digit. The 1 is a non-zero digit, but these are zeros, so they do not count. Second rule states trailing zeros are not significant. Trailing, you guys understand, is anything that is following behind. So if I look at the first example, we have a non-zero digit, which is 1. These 3 zeros are following, so these are trailing zeros. So they are not significant, so there's only 1 significant digit. 7 and 3 are non-zero digits, so they are significant. But this 0 right here is following, so that is not significant, so there's 2 significant digits. Pause the video, try 3 and 4, and check your answers. Number 3, you should add 1. 9 is a non-zero digit. These zeros are all following the 9, so they are trailing zeros. For 4, all the numbers before the 0 should have been significant, so you should have 6 significant digits. This is a trailing 0 because it's following the other non-zero digits, and so it does not count. Rule 3 states zeros surrounded by significant digits are significant. So if we look at example 1, 1 in the front of the 0 is significant. The 1 after the 0 is significant. Therefore, this is surrounded by a significant digit, so it is significant. So this one has 3 significant digits. Number 2, there are 2 sets of zeros. We have a 0 here and we have a 0 here. The first set of 0 is surrounded by a 7 and a 4, which are both non-zero digit, therefore significant. So these zeros are significant. This last zero is also significant because it's surrounded by a 4 and a 1, which are non-zero digit, therefore significant. So every single digit in here is significant. So this one should have 7. Pause the video, try 3 and 4, and check your answer. So for number 3, there are 5 significant digits. The first set right here is surrounded by significant digits because they are non-zero digits. So 7 is non-zero, 1 is non-zero. So these zeros are significant. The last set of zeros are called trailing zeros. So these are not significant, so there should be 5. For number 4, there should also be 5. These zeros are surrounded by significant digits 7 and 1, so all the zeros are significant. Rule 4. For scientific notation, only the first part of the number is significant. So if we look at example 1, we have 3.00. This is the first part. The second part is the exponent. We ignore the exponent and count everything in the first part. So there's 3 significant digits. For number 2, again, we ignore the exponent. Do not expand these out. If you expand these out, you will count them incorrectly sometimes. So there's 2. So pause the video, try 3 and 4, and check your answers. So for number 3, we ignore the exponent, count everything in the front, so there's 4 significant digits. So for number 4, we ignore the exponent, count everything in the front, so there is 6 significant digits. Again, do not expand these out because sometimes you're going to make an error if you leave decimals in. The most difficult rule for significant digit is Rule 5. Numbers with decimals present. So the decimal is written in the problem. In order for number 5 to work, both A and B must be true. First, there must be a decimal given anywhere in the number. It could be at the beginning, it could be at the end, it could be in the middle, but it has to be written in. B, there must be a significant digit in front of the 0. If both A and B are true, then those zeros that follow are significant. So let's look at example 1. The zeros are present right here. So if I look at point A, is there a decimal present? The answer is yes. The decimal is right here. It's written in. So I go to the front of the zeros. Is there a significant digit in front of that 0? No. Since B is not satisfied, these zeros are not significant. These are called placeholders. So there's only one significant digit. That's the 3. So for number 2, this is the set of zeros. We're going to determine if it's significant or not. So A, is there a decimal present? Yes, it's given to you right here. B, is there a significant digit in front of those zeros? Yes, the 4. That makes every 0 that follows the 4 significant. So here there are 5 significant digits. Pause the video, try 3 and 4 on your own, and check your answer. In number 3, there are 2 sets of zeros. We have a set of zeros here, and we have a set of 0 here. So let's look at the first set of 0. Is there a decimal given? Yes, right here. Is there a significant digit in front of those zeros? No. So these zeros are not significant. These are called placeholders. Let's look at the second set of zeros. So if I look at the second set, is there a decimal given? Yes, right here. The decimal is given. Is there a significant digit in front? Yes, there is, this 1. So that makes all these zeros significant. So in number 3, there are 4 significant digits. In number 4, there are 2 sets of zeros. We have a set here and we have a set here. So if I look at the first set, is there a decimal present? Yes, it's written in. Is there a significant digit in front? Yes, the 3. So those zeros are significant. The other way you could determine this is the zeros are surrounded by significant digits, 3 and 1. Therefore, the zeros are significant. Now let's look at the last set of zeros. Is there a decimal present? Yes. Right here. Is there a significant digit in front? Yes, there is. So those zeros are significant. So for number 4, every single digit is significant. So there are 9. In general, if you have a decimal present and the first set of zeros are significant, every other zero that follows will be significant. But remember, the decimal must be written in. Pause the video, try these problems on your own, and check your answer. So for number 1, there are 4 significant digits. The 0 is significant here because it's surrounded by significant digit 4 and 9. So every digit in number 1 is significant. Number 2, there is only 1 significant digit. If I look at the first set of zeros here, there is a decimal present, but no significant digit in front. So these zeros are considered to be placeholder. So there's only 1. Number 3, there are 3 significant digits. Scientific notation, we ignore the exponent and count everything in front. For number 4, there are 6 significant digits. There are 2 sets of zeros. We have a 0 here, and then we have the second set at the end. So is there a decimal present? Yes, right here. Is there a significant digit in front? The 3. Therefore, the 0 is significant. Or the other way you could done this, the 0 is surrounded by a significant digit 3 and a 1. That makes the 0 significant. If I look at the last set of zeros, there's a decimal present, significant digit 1 in front of it, so all the zeros here are significant. Again, if there is a decimal present and the first 0 is significant, every 0 that follows will be significant. Number 5, we have 2 sets of zeros. We have here, and then we have the second set between 1 and 3. So the first set, is there a decimal present? Yes. Is there a significant digit in front? No. So these are called placeholders. The second set of zeros is surrounded by significant digit 1 and 3. So these zeros are significant. Or there's a decimal present, there's a significant digit in front, therefore the 0 is significant. The last set of zeros are also significant. Why? There's a decimal present and a digit that is significant in front of it. So this one has 6 significant digits. Number 6 is an exponent. We ignore the exponent and count everything in front. So there is 3 significant digits. Only these count, all of it. Number 7, there should be 3 significant digits. We have a 0 here and we have a 0 set here. The first 0 is significant because it's surrounded by significant digits 1 and 3. The last set of zeros are not significant. These are placeholders and they are known as trailing zeros. Number 8, there's 3 sets of zeros. We have here between 1 and 3 and after the 3. The first set, there's a decimal present, no significant digits, so these are placeholders and not significant. The second set right here is surrounded by significant digit 1 and 3, so it makes it significant, or there's a decimal and a significant digit present. The last 0 is also significant. Why? There's a decimal present and a significant digit in front of it. So this one should have 5 significant digits. 9, exponent. We ignore the exponent. We count everything in front. So even though the number doesn't have a decimal, this one will have 5 significant digits. The last one here, we have 1, 2, 3 sets of zeros. The first 0 is not significant. There's a decimal present, no significant digit, does not count. The second set of 0 are significant because there's a decimal present and a significant digit, or it is surrounded by a significant digit. Therefore, these are significant. The last set of 0 is also significant because there's a decimal present and a significant digit in front. Or if the first set of 0 is significant when a decimal is present, every 0 that follows is significant. So the last one should have 8 significant digits. To be successful in calculating with significant digits, you need to be able to identify which digits are significant and which are not. So if you're struggling, do extra practice so we can move on to calculations.